You can call me Adi. Yeah.
Okay, so after DC 949 thoroughly ruined our schedule, we're ready for the next talk. This is Mangling with Botnets by Aditya, Sood, and enjoy.
Hi everyone. I'll put it there. First of all, thanks to everyone for attending my talk. And so today we are going to talk about mangling with botnets. So typically I'm going to take you to the journey, how about the botnets nowadays are working. It's not about a standard like 10 years back, like how the botnet do like denial of service attacks and sort of things. It's something that I have this kind of information over which the talk has been based on, has been extracted from the kind of work I'm doing over my thesis. And it's not a kind of theoretical talk. I have some really interesting demos, but I'm not going to run in a real time. So I've made videos over that. So let's get it started. A little background of mine. I'm an independent security consultant, but right now I've been working with ISEC partners, and I'm a PhD candidate at Michigan State University. So all the work that I've done during this talk has been done with my advisor. He's not able to come here, so that's why I'm the only one that is delivering this talk. So agenda. So today we are going to talk about the browser malware taxonomy, a little bit about the malware life cycle, then how the actually bots are getting implanted, and the information stealing tactics of present day botnets. And then I'll be introducing the one of the finest two new botnets in the right present time, that is called a smoke bot and the ice bot. And we'll be going through that command and control panels and see how things works. One of the things, the smoke bot has not been discussed in detail, so we're going over it and try to see how the design and things work here. So before laying the foundation of this talk, I really want to talk about the FUD, like the fear, uncertainty, and doubt. Any malware or any malicious sample that exists in this world is based on these three things. I mean, it exploits these kind of stuff in humans, like you're fearful, uncertain, and when you're doubtful. I mean, you're clicking some link and you don't know what is going to happen at the end point. That really gets exploited. That's why FUD is everywhere. And even if you go into the underground forums and try to search for different kind of samples, the malware utilizes this term a lot, FUD. And which is also being taken for like obfuscation, the kind of how they encrypt, decrypt, apply polymorphism, and kind of other obfuscation tactics to hide and stealthily execute the code. So it works a lot. So what is the paradigm of malware? I mean, what they want? At last, they want your information. Yes, that's true. And what they are going to do with that information is like identity theft, scams, and sort of other things. It lies there. And it still persists. It was persisting like 10 years ago, and it's still going on pretty strong. Who is it? I mean, who are the guys behind spreading botnets, spreading bots, and kind of other things? Who are those guys? What they really want? They are hidden. They can be anyone. But the reality lies in the fact that you don't know which is present at the interface. And behind the interface, the real malware guy lies. And that is the reality of present day. And that is happening at a really fast scale. For example, with the advent of third generation botnets, Zeus and SpyEye. And the botnets that I'm going to discuss today is the extended version of those. So I'm not going to talk about anything SpyEye and Zeus, but some of the techniques that have been started used by the present day botnets. Yeah. So the interface is different, but the identity that resides behind it is completely different. Now, so prior to discussing like different set of topics that I have during this talk, I want to lay the benchmark of browser malware taxonomy. I mean, why we need a taxonomy? I always used to ask this question to me. We need taxonomy because we want to build defenses. And in order to build defenses, we need to segregate the malware from one part to the another, which means we have to classify the malware. If we are not able to classify the malware, we are not able to build strong defenses against it. So here is some of the last year I proposed this taxonomy, released this stuff in Virus Bulletin, and it's all about 3 classes of malware that typically exploits the browser functionality. First one is a class A, browser malware. What that's supposed to be. It's kind of malware that resides inside a browser process. That means any add-on that gets installed in a browser exploits the integrity of browser process, the main browser process, and they don't have to perform any privilege escalation and sort of things because all the functionality and the access rights they get by default. And that actually resides. So that's why the diamond box lies inside a browser process. Let's get on to the class B. So the class B malware actually exploits the integrity of plugin architecture in browsers, which is a third party, right? Flash, Adobe, Java, and sort of other things. So the malware that actually exploits the vulnerability in these plugins is the class B malware. And what it's going to do afterwards, drop anything into the system. But the entry point is the plugin architecture. Since plugins are sandboxed, they have to really perform the privilege escalation, which means they have to exploit a vulnerability in those plugins. Adobe Flash persists for a long period of time. And talking about the class C browser malware, what that's supposed to mean. It's a kind of malware that may be exploiting a functionality of class A and class B to get entered into a system. Basically a user land or can be a kernel land. And that's why the diamond box has an interface between the operating system kernel and the plugin process. It can be anything. It resides in your system, user land, performs DLL injection, performs registry hooking, API hooking, and sort of these kind of things to manipulate the normal functionality of the operating system. But again, the entry point is through browsers. So they exploit something in browser, one or the other way. So these are the 3 classes of browser malware which we really need to understand to jump and delve into the further concepts. So talking about the botnets, it's really good to talk about the malware life cycle, how the malware actually gets into your system. Can be anything. So I always used to say any malicious sample or any malware actually exploits the human first, then the technologies. Maybe it's an automated antivirus system solution, perimeter security you have deployed, or any sort of things, active monitoring system. But web, which is a port 80, always open, right? And you have a browser which is an interface to the internet. So it exploits you first, then the different set of technologies which we used to call bypassing antivirus systems, doing any sort of things, maybe using obfuscation services and sort of stuff. So talking about a malware lifecycle, I'm pointing to a Java exploit, which may be SMB or any sort of things which is being used by the browser exploit packs. And how that steps work basically. In the step 1, what the attackers try to do, they actually try to exploit a system, maybe a high volume website, maybe like share web hosting, any kind of thing where the traffic is really high. So what they want to do afterwards, they simply plant malware, which can be accessed by anybody from the third-party domain. And so I've been pointing this out as an analyst, how you have to analyze the things. If you look at once the vulnerability in a specific website is exploited, then you are going to detect malicious iframe in that website. Being an analyst, I have to go through the source code of that page and how we can do that. We have a different set of Linux commands and sort of other things, how we actually analyze it. And we have to extract what kind of patterns are there, maybe like obfuscation patterns and simple iframe, hidden iframes, where they are pointing to. That's the point is. So once you do that, and typically some of the analysis point, we don't prefer to run in browser, emulate it, and the preferred way is to fetch it using wget curl utility in the Linux systems. Try to get a raw source page. So what happens afterwards? It might be a bit blurred because of the solid color at the back end, but typically you extract the iframe and try to see where the third-party domain is, right? Where the iframe is pointing the third-party domain. Once you do that, you try to access those web page, which is another second level web page, and try to download the system specific malware. So here it is like a Java file, which can be a jar file. You have to decompile it, maybe different thing. Another point is the system can be pretty stealth. If you install a Java plugin or maybe you install a Java applet, it can run through JavaScript exploitation, which you used to call a heap spraying and all that, and can be executed in a stealthy manner in your system. So you never know. Typically, if you have used in penetration testing, called as like set framework, social engineering toolkit uses this kind of technique a lot. So while analyzing malware, analyzing botnets, this penetration testing, web app assessment, malware analysis, testing apps on Android, all things get into a circle. So if you know all the skill sets really well, the results are pretty fruitful. So that's what we used to do, and the results are pretty good. So at the last, the malware gets installed in your system, and that's how, if you decompile that file, so supporting my concepts here, I'm actually discussing all the case studies that I have here. And so if you look at the source code here, it's like in the Java, they actually embedded the VB script file, and through DOM, document object model in browsers, while the Java is rendered and the things get executed as a scripting way. So this is a very typical format, and it's pretty good, like VB script, which is being known from the days of VB language, Visual Basic. It's still persisting pretty well, and the attackers are still exploiting these things. So after discussing about the fact that what a class A browser malware is, class B browser malware is, and class C browser malware is, we are going to look at the present day techniques, how the bots or the malware is getting implanted, and how the system on the web are getting exploited, and how it gets into your system. So after this, I'll be running some pretty good demos and all that, but that's all like recorded videos, so that we don't waste time if it's not run properly. So the very first thing I want to lay stress is like exploiting web hosting. So most of the data centers or like virtual hosting servers have a capability to host different set of virtual hosts on a single server. Maybe they are not dedicated, but they are like 10,000 websites are hosted on one Linux platform. And it has been seen previously, like we presented, have written paper on this exploitation of web virtual hosting, how the malware writer does, and it got in the Hack in the Box ESA, and it's available. If anybody interested and can download, it's freely available. So data centers are the really target points, because why the attacker have to go on one website, which is have a high set of traffic? Why it's not going for like web virtual hosting, where you get like 10,000 of websites, right? And the real trifecta lies here is the fact that if the 10,000 website, if an attacker find a vulnerability in one website, for example, file uploading functionality, doesn't have an appropriate sanitization and other sort of things, attacker is able to upload maybe through HTTP verb jacking or maybe through HTTP web DAV methods. The attacker is able to upload anything on the web server. And they have written some of the very sophisticated scripts, like C99 shell, been existing for a long period of time. And nowadays, our study has shown that they are using automated iframers. What these kind of program does, like once one website is compromised and the attacker is able to upload like automated iframer script, so all the 10,000 hosts on the dedicated virtual server is going to be infected with that particular iframe. So you run that Linux script, it's going to go every directory for a particular host and embeds the iframe in it. And so you can look at this as a kind of chain exploitation, or maybe exploiting a co-location hosting, and that works pretty well. And within a one speck of time, 10,000 websites are infected, and you must have seen like some of the cases that had been discussed in the media within last year about this. And this is some of the code snippet which is used to inject automated iframes in different hosts. For example, main web files, index.html, default.html. So it works. So this has been taken from one of the case studies that we have analyzed, and it worked pretty well. So that's why the exploiting web hosting is really one of the major tactics that attackers are using to implant malware. And again, it's an example of some sort of C99 or other shell which actually shows you how the privilege escalation can be done pretty easily. Once you upload the file, maybe you are in a restricted user, there are ways these shells work pretty well and at least give you that specific set of information, reading password files, which you can use to compromise the web server later on. Now, another interesting study which we have did recently, like about infecting the glide proxies. So glide proxies are open PHP scripts which are being used at a heavy scale for anonymous surfing. And why this works pretty well, because in some of the organizations where you have a restricted traffic surfing, where you can't surf some of the set of websites, that's where people used to go, employees used to go to the open glide proxies and try to surf Facebook and sort of other things. And because since it's open, they can use that and it's not being restricted at the perimeter level of the organization. And it is being used for a heavy set of infection nowadays. And this glide proxy, since open, you can make more modification into the PHP code. It's an open source, so you can do whatever you want. So here is a simple example, a small demo which actually show you while you're surfing a particular website, for example, facebook.com through glide proxies, how we can inject certain sort of things so that all the proxified web pages are embedded with some sort of malicious scripts and other things. Small demo which can gives you a better understanding how one can abuse the glide proxy for distributed infections. We used to call it distributed, not targeted, because users from different countries or different places can visit glide proxies to get the things done. So what I'm doing here is that I have hosted this glide proxy PHP source code on one of my server, and I'm going into setting.php file and try to show you what kind of different setting this glide proxy script provides. So basically it's like a centralized configuration parameters you can do based on the configuration scripts. This is a very simple proof of concept I'm showing, just try to back up the argument that I'm making in front of you, why glide proxies can be abused and they are getting abused. So this is a small jQuery plugin we wrote and we put into footer of every page. So what it does, every time a user will log in into a glide proxy and try to surf through any website, after the proxify module, when the proxify module runs, this script will be executed in every script page. Again, this glide proxy provides a hot linking within a certain set of configuration parameters, and adding some of the additional code you can remove the hot linking to. So you will not get any sort of glide proxy bar in it, and that will look legitimate. So when anybody uses opens a Facebook web page here, since glide proxy supports plugins for Facebook, Twitter, and other things, so that's why it's get rendered in this way, because Facebook has implemented some sort of cross domain sharing and restricting sort of frame busting defense. That's why you cannot frame it. So you have to use some sort of APIs to actually write a plugin. So what I'm doing here is that I'm just adding any random credentials, and at the bottom you can see that in the proxified web page, the script has actually get inserted here. So what it does, so you want to log in into Facebook, you provide your credentials, now what? So we'll go back on our command and control panel, which is in case is my server, and I'll show you. So this is a simple login script. It's a logger we have implemented. Any post request that comes from the client will get logged into the text file. A very simple POC to show how glide proxies are being abused. So this actually show you whatever the data is being entered by the user is actually gets logged in. So it really becomes hard while surfing through glide proxies, and it's really hard to determine that whether those glide proxies are doing some malicious stuff or not. But this actually simply shows you within a simple small jQuery plugin that you might want to extend the functionality of glide will actually leverage you a lot of functions and a lot of exploitation routines that you can write to extract a lot of credentials and a lot of information out of user's machine. So that was the one simple demo. And the another one I will be talking about browser exploit packs, automated frameworks. So Black Hole, you might have heard that name, Phoenix, and a lot of other things. The Black Hole, we did a in-depth study on the Black Hole exploit pack, and we presented that study in Virus Bulletin conference, so the details and the paper is already out. And so if you look at this one, the browser exploit packs is an automated framework. For example, if you use Metasploit, so Metasploit has a browser autopon. module. So that the Autopon module was actually based on the design of browser exploit packs. So all the exploits are bundled together in a one framework. Whenever a user visits a malicious website, the browser will be fingerprinted, and if there is a vulnerable version in plugins, or if there is a vulnerable version in the browser component, then they are going to serve the exploit. And the exploit runs in a hidden manner, in an obfuscated manner, and actually your system gets compromised. And in order to make operations more still so that you cannot reverse engineering the source code of some of the PHP files that the browser exploit pack uses, so most of these exploit pack writers and authors use a PHP IronCube encoder. It's a very good encoder, and you cannot read the source files pretty easily, even if you compromise the command and control server. So you have to do behavioral testing in some sense to get the source code out of it, how they have written the Java exploits and some sort of thing. One of the case study we did on Phoenix exploit pack, where we seen that the exploit pack was actually using exploit from the Metasploit, which was written in Ruby, so it was directly using the exploit. But it works pretty well. So the browser exploit packs are used in collaboration with botnets. So the payload can be anything, any malicious binary. So what the builder does actually, when they actually install a browser exploit pack, the payload actually holds the bot, maybe a Zeus bot, SpyEye bot, Smoke bot, or NGR, or maybe another sort of one, which one can be an iSpot too. So when the exploitation is a success, the bot gets downloaded into your system. It may be a dropper or whatever, depends on the design the attacker want to use. So I'm pointing into a Java SMB vulnerability which was exploited the most by the black hole in doing it like a diversified infections, but it works pretty well. So coming to Java SMB exploit, that's how it crafted. When we analyzed it, it's like a VLC media player file. So they try to use obfuscation or like an extension mismatch, but the code is actually executable code. So if you remove the VLC extension and then maybe like an AVI extension and then change it to jar file, so it's actually a Java file. So you decompile it, you get the source code. So these are the small tips and tricks you always want to apply while you're doing malware analysis. Comes with the very fruitful results. And the another one is like with the advent of browser exploit packs, there is like a drive-by frameworks. So drive-by download is a simple attack where you forces a user to visit a malicious domain, and then the browser actually gets exploited and your system is compromised in a hidden manner. So this is the latest, the NNJDB released like within a spec of like 4 to 5 months. Works pretty well. It's a Java drive-by download framework and try to exploit vulnerable versions of Java and then connects back to the command and control shell. So it actually gives you how many systems are being compromised and to where the payload has been loaded. And if you look at this scenario, this actually shows you the glimpse, the number of infected machines it has and how it's making the system to be vulnerable and making it compromised. So the point is like the automated frameworks play a critical role, which actually gives us the point that maybe the attackers don't have that kind of time, maybe the underground criminals don't want to spend that much amount of time and they want to do something very fast. That's always been there. And let's take a look at the demo of the black hole exploit pack. Just try to show you how exactly drive-by download works. So you might need to pay a bit of attention because this attack works in a stealth mode. You might not able to get, but I try to show you like how the traffic is, being connected between the domains and how the malware is being served. So it's a full malware life cycle, how the drive-by download works. So it starts with like user simply logins into the email provider and try to see any kind of email that he's been receiving. And so he found that there is a very interesting link, luring link, maybe it's there. So they always used to say like think twice before you click. It's really hard for the users to go with that. So what happens, user find it pretty luring and try to click the link. So the browser actually gets redirected to the fake Facebook page. So you might not able to detect or find anything, but if you look at the source code, This is an obfuscated iframe is there. And it's compressed, it's obfuscated, it's really hard to analyze. But since you have already visited that page, it means something has already happened. So it actually show you how the iframe is being rendered. It's not easy to decipher it, but it's there. So it looks legitimate in that sense. Maybe it can be any page. So if you look at the traffic, it will show you that when you click that link, it gets redirected to some another domain. And that actually serves like you send a GET request from that page, because when you visited that page, actually the iframe gets rendered and it has to fetch that third-party URL link or whatever it is serving with the malware or maybe any malicious script. So it did that. And you can see that all the HTTP requests are filled appropriately. It's like a 200 OK message, and there is a permanent redirect to the another domain. So now what happened in your system? You don't know. So what we did, like when it worked, so we tried to do a small scan, and this malware by itself is an antivirus system but has a good scanning engine and a good update for the signatures. So it can it can basically detect this uSpot if it's get infected. So it gives you an idea how this try-by download is working, from hopping from one domain to the another and then downloading the content into your system which you are not able to see. So it actually communicated back with the black hole exploit pack, which has this kind of command and control interface where you get a lot of statistics and all that. So it depends on like where the domain is, like the third-party domain from where the browser is actually downloading the malware. And so if you see like the system was clean and it actually gives you a one alert, and it was like a ZBot, which is actually a uSpot, and that actually get installed your system. But since this was like an old version, so the signature was there and the antivirus was able to detect it pretty fine. But the overall point in showing this just a little demo is that how the drive-by downloads work. So you force a user by sending a spear phishing email and it still works. So phishing, I think it's been known for like quite a lot, number of years, right? But it still persists pretty one, and it can be used for targeted attacks and sort of anything. But that's how the black hole exploit pack works and how you use phishing and drive-by downloads to work together. Let's get on to the malware on the cloud. So we came across with a very interesting study where we find that analyzing something and came across with this fact that Amazon AWS services were actually act as a storage bins. So how the cloud works very simply, it provides like access to different number of hosts who actually gets the services from Amazon, and every host has this individual bin. So now you cannot scan that because you need to have a host API key, and Amazon don't allow you to scan their web cloud infrastructure, but they provide bins. You need to have an explicit path to the bin where the malware is being hosted. But we came across with this fact, and this is a malware which is actually a package installer, has like a 10 or 15 binaries, and you get that, you download, and you came across with this fact that there are a number of files, the DLLs and sort of other things. So being is like responsible disclosure, so we sent a tweet to Amazon, they removed it. But the point is here is that even the Amazon, even the cloud structure is not untouched by the malware. So malware is already on the cloud too. Since it actually reduced the business perspective of Amazon to allow the third-party vendor websites to build a scanning engine that actually goes across through your cloud structure and then gives you some results. But if some bin is compromised, you get a host key, you get a credential, you can host the malware. That's what attackers are doing. And talking about the malware on the cloud on the last slide in this case study, so if you look at all these things, all the things in red, These are the names of the binaries that are malicious in nature, but has been undertaken by the malware bytes. So this try to gives you an idea that the package installer is malicious and has a 10 different set of files which can be droppers or extended malware. And let's take a look at another fact is the social networks. I mean, it's there, and we are going to try to run a small demo tool, try to show how the social networks like Facebook and Twitter can be exploited, or how we can inject some kind of malicious tweets or malicious likes in that. Used to call it like jacking, always been there. So with the passage of time, like last year to till this point of time, we've been analyzing a lot of case studies that are using like jacking and click jacking collaboratively and try to force a user to inject a malicious link into the Facebook profile through like jacking. And then the user thinks that, okay, it comes from my friend, it can be legitimate, I can click on that, and the whole process of drive-by download works. And then there comes the automated drive-by frameworks which do the infection. So let's take a look at this one, how the like jacking works. So it basically exploits the like functionality. If there are two users communicating and they like something on Facebook, so they click, okay, I like that your part, and then distribute it across the chain of users. And so this is a similar user I have. I logged into my account, testing account, and this is the like jacking page. So if you move your cursor over it, you can see that there is a like page. We can make it hidden. It's based on the JavaScript, how you write. So we actually got this JavaScript from one of the malware domain, tweak it a bit to make it unhidden and make some changes. And I'm just setting up a traffic control here so that you can see how the traffic is being communicated with the Facebook. So this is the like jacking source code. So here I'm going to click, and you can see that the request has been sent to Facebook somewhere. The first thing we're going to see whether Facebook accepts that or not. And you see there is an HTTP 200, okay, it means Facebook accepts it. And we go back into my account and refreshes the page, and you can see there is a link out there which actually is pointing to some third-party malware domain. And you go there, it's a simple payload. So actually I backdoor the Windows Media Player file in it. So even if you go through the web page, right, you will not able to see that from where the malware is coming up. So it is actually embedded itself in the Windows Media Player. So we actually scripted that and try to inject iframe in it. But you can see the traffic, and you see that whenever you visit that page, so the malware will start downloading into your system here. So the point is that you can make it hidden as much as you can. You can make it stealth as much as you can. But for this demo, it just like try to show you how the things work, and that's how like jacking works. So now we are jumping on to the present day botnets, information stealing and manipulation tactics. What kind of like the tactics these botnets are using? It started with Zeus and SpyEye as a third generation because they have a motivation to impact the financial industry and the banking industry. Some of the techniques, how they have developed and originated during their design phase, has been used by the present day botnets. And the first one is a form grabbing. So it came with the fact that when the malware is installed in your system and you're writing something, typing on your keyboard, and there's a lot of garbage data through keyboard logging, right? So they came across with the fact that we don't need that. We want that some sort of information that is pretty compressed, optimized, and that is to the point. So they came across this fact of form grabbing. And they thought, like, if your system is already infected, what can we do more? So if you remember, it's a port 80. Browser is going to be the window. And so they start exploiting the browser inherent functionality here. So how do the attackers do that? We are going to take a look at it. So the form grabbing works pretty fine. So anything you submit through a form will be grabbed by the bot and will send back to the command and control panel. Okay, so you start surfing your Chase Bank website, and then you put your credentials over their account number, everything, you submit. So the bot is actually present in your system. It hooks that request, send it back to the command and control. Even present day Android malware is also doing these kind of things, depending upon how they collaborate with the botnets. And that's how it is being done. For some of the samples that we have analyzed, they actually perform DLL injection. So typically in previous times, we have a three type of DLL injections. We have an API hooking, then we have a registry, and then find Windows, set Windows, hook EX, and Windows operating system. But in this particular case, some of the recent samples, we have also seen that the malware started using APC-based, asynchronous procedure call-based hooking too. But that is not a part in these samples that we analyzed. So it breaks Firefox, it breaks IE, it simply hooks the DLL into your Firefox process, which we used to call as that uses a dynamic link library, IE Explorer. And then the Firefox process, they have a respective dynamic link libraries, which are being hooked by the bot. So whatever the traffic is going through it, for example, whatever the data is going through it in the form of GET or POST request, it hooks it, send it back to the command and control panel. That's pretty easy because they are already in the system. And that's how it works. So your SSL is not a solution against it, because it's a man in the browser attack. It works pretty fine. Came from man in the middle. And with respect to mobile, there will be a man in the mobile too. That's already been there. So two-factor authentication is not giving much difference with that, because if you're using a web-based forms, it's completely different. The layers are different. So they actually exploit CDLL hijacking technique, typically aimed for exploiting online banking. But since the concept is pretty generic, it can be used against social networking websites or any websites where you provide your critical information that is used for getting access to your accounts. And if you get into the web injects, after the form grabbing, it again based on the concept of man in the middle, basically man in the browser, I would say. So the web injects is a very simple technique. Again, the malware resides in your system. So they came across with the new fact that why not to start injecting some malicious content in the incoming HTTP responses. For example, you send a request to facebook.com and the Facebook, accepts that request and sends back you the content, right? So the bot is there since it's already hooking the dynamic link libraries. So the incoming traffic, the bot actually has a particular kind of web injects.txt file. So based on that rule set, it can inject different kind of parameters. So you can see it can inject any kind of input box, it can inject any kind of JavaScript that gets rendered in the browser as soon as the browser opens the content. So it actually came with Zeus, then it came with SpyEye, then all the other botnets, Smoke, the iSpot are using this technique. But there is no typical defense against that. So in my thesis part, we are working over it to build some sort of defense. Asymmetrical one, where we try to reduce the impact of these kind of infections. And that actually gives you an idea how the web injects rule look like. So if you look at the scenario, it has a three different set of tags: data before, data after, and data inject. So where you want to inject in a web page, what kind of data you want to inject in a web page, and to which part you want to inject the data. So you have to render all the page here, works through the plugin framework. As soon as the system is infected, it reads the web injects file. Okay, there is a chase.com. I want to inject some input field and try to extract some more information out of it. So it works pretty fine. And since SpyEye has a web injects kind of thing, typically designed for Bank of America, they used to call a BOA grabber. It works pretty fine. So this is another interesting technique. And when the web injects work, it looks like this. And it gives you an idea. That is a rule set file. And if you look on the tab, the title bar, you can see that there is an inject happen actually. So this is a very interesting technique. I mean, again, the attacker can force you to provide the information he wants, right? And that really works in web injects here. Another one is a web fakes. So if you go into recent, you must have seen there are a lot of DNS changing malware or that actually manipulate the DNS settings in your system. And this is another plugin framework that present-day botnets are using called as a web fakes. They simply do once your system is infected, they again have a web fake.txt file, which has a set of rules. So if you want to visit a chase.com, the browser will automatically redirect you to some another domain. So typically asking how the DNS changing malware works. So you can put up an entries in etc host file if you are on a Linux, or host file on Windows. Or based on the DLL hijacking or DLL injection, you can typically exploit all the files that a particular DNS is using on the client side. So again, you can hook and redirect the functions to some any third-party domain you want, and it works pretty fine. And that's actually some of the function calls that Spire uses. And this actually gives you that the Spire kind of botnet actually uses a bot development framework, a term that is coined from a software development framework. And they have written their own function calls in VC++. And whenever you write this function, it hooks and performs the web fakes for you. And that's how they do the things. Again, it actually try to map up the patterns when you're sending a GET request and the POST request. So they based on the concept of callback handlers. So you get a GET request, it calls back something and perform this functionality. And when you do that, a typical example works in this way. You try to open something, the Bank of America website will look like this. And that's how the web fakes actually work. Other information stealing tactics actually include a plugin architecture, which can be a credit card grabber, certificate grabber, SOX backnet, FTP backnet, RDP, distributed denial of service. And the latest one is, which we have seen, is the webcam hijacker, which we call a flash cam control. Maybe the development of SpyHi has stopped, and there is no more development taking place from the Spy botnet. But some of the custom-made modules like these webcam hijacker, they are still in testing phase. We haven't seen some kind of things, but it's been there in the wild. And if you do that, it typically exploits the flash functionality and typically exploits the flash settings file in your system, made some manipulation in that, and whenever you try to do something, it automatically starts your webcam and microphone to start recording and then transfer that file to the command and control in the flash format. It's there, but the typical ones are the web injects, the form grabbing. These are the two most exploited techniques that are used by present-day botnets. So let's talk about the smoke bot and the ice-bot. I think it has not been out yet, the smoke bot, but try to give you overview how it works. And we'll go through these command and control panels, and the last demo I'll be showing you how the form grabbing works and how the attackers steal sensitive information if they open the websites. So the smoke bot command and control looks like this. So it gives you an idea how the bot panel works. It's a new bot. It's very effective, implements some of the really interesting tactics for hidden execution. And if you look at the bottom, it has some options right there. If you want to run your malware as an executable, you want to use load library, DLL injection technique, or you want to use a simple registry server 32, try to install the malware as a service, or maybe using any registry based entry, and then it can do the trick. So let's just a small walkthrough for 1 minute over a command and control panel, how it looks like. This actually gives you an idea so where the infections are being taking place throughout the world and to what extent there. So when we actually capture that video, it was an initial stage at that point of time, but it's a very effective bot. So you get this kind of option it provides. So even if you look carefully on the first page, it has a lot of infection on the Windows x64 operating system too. So it's not only related to x86 typically. So that's how it builds up the text files, which has your all information. So I want to lay a point here that this information not only relates to the information that a bot captures from the browsers, but all kind of information, your Cisco VPN client credentials, Windows admin users, remote access service, RDPs, FTPs. So it captures all. It's a very effective bot. And it also builds up a shell for every IP address. So if there is a 10 infected system, it's going to build a 10 different shells. So from shell, you can send a command back to the infected machine. And that's how the smokebot command and control panel looks like. And the last one I'm going to talk about is iSpot. It's an advanced version of Zeus, you can say. Some really good changes in this bot actually from the Zeus perspective. It is as effective as Zeus 2. And this actually gives you an idea how the command and control panel looks like. If you go here, this is a form grabbing in action, the technique which we had discussed earlier. And this actually shows you how the data is being captured on the command and control panel. So to give you the interactive view, we're going to look at the demo here. So here is the bot. So we actually try to execute this bot in an emulated environment. This actually gives us a simple executable x64. So we are using an Windows XP in a virtual environment. Okay. So when we refresh it, the bot is gone. So in malware terminology, in attacker's perspective, this process is known as melting. So the drop, it can be a dropper, it can be any kind of malicious program that melts itself to throw up any second level program into your system. So at this point of time, we are logging back into the command and control panel where we have set up the NGR bot. Sorry, the iSpot here. So if you look at this scenario, so all these systems are infected and communicating back with this command and control panel. If you look at our IP address, you see the system has connected back to the command and control panel here. So our system is infected, it's communicating back with the attacker server. Now that's the real point comes here where the form grabbing place is sparked. So I open a Chase account here and I want to log in into account. Maybe at this point of time, I'm not using any real credentials because there is no point of using them. So I use any fake credentials and try to submit. So just try to project that this attack technique is not only aimed at exploiting banking infrastructure or banking website. It can work on any website because the concept is pretty generic. So I'm just sending any random information in these input boxes to just submit the form. So when I go back onto the command and control panel here, so you'll see there is a one request from Chase that has been logged and it comes from the infected machine. So if you look at, it gives you the bot ID, some of the stats they use to collect. And if you go at the end, you see that how the form is submitted from the infected machine. So the malware writer becomes more sophisticated. They are also using the key logging technique. So the user inputs some sort of data. It also gets logged there. And at the back, you get a form grabbing. So this actually shows you how that form grabbing works and how that they steal information out of it. Again, on the Facebook one, so you're logging into your account, you don't know what is being there. So I go back into command and control panel, refreshes it. I get another request from Facebook, from the infected machine. So you can see that all the data here, so all your credential, passwords and everything is here. So this technique works pretty fine and it's very, very effective. All the present day botnets are using it, form grabbing, web injects, web fakes, and that has really made the problem really harder. And what happens at the end? Now this data is not yours. So these are all the credentials. This is actually taken from the log files of the smoke bot, and you see that all the browsers are being compromised here, one or the other way. And Google Chrome, and we have all Opera, Firefox, all are vulnerable to this kind of attack technique. And the next one, not even that, because it actually gives you idea that even the Windows credentials, Cisco VPN client, Outlook credentials, ScamFrog, Titan Poker, everything is on. So at the end, the data is not yours, and that's what the attacker wants. That's what the botnet operator wants. And once they get your data, it's all about processing the data, which gives them the information. And the information is a key to every attack here. So I just want to conclude some points like, it's the truth that we were and we are still living in the age of botnets. The problem is like a cat and mouse game, which is really hard to eradicate. And again, it's the main point. Remember, malware exploits you and me the first, not the technologies. And I think we are left with 5 minutes. Any questions? Yeah. I think in the last couple of months, like 2-3 months, there is a Flash OS X malware that came to exist. Yeah, but again, it was using some vulnerability in the plugin architecture. It's third-party plugins, right? I think it was in Flash and all that. But Linux, I don't see any much. But that's why I used to say always, like, I love Microsoft because they give the malware industry and the business to the anti-malware vendors. But still, if you look around, it's most of is like a compromising the Windows machine. It started with Mac OS X too, and it was like one of the largest one in Mac OS X. But I think still, as compared to Windows, the infection is still rare and less. That's the thing is. But Windows is like cure Windows, right? And thanks to Microsoft for that. It's a huge business.
They have a table in the vendor area. You can thank yourself.
Yeah, well. Yeah, from that perspective, it's good for them too because they are building solution and selling them, right? So thanks a lot for the LayerOne conference crew for giving me an opportunity to discuss some of the concepts that I have and some of the people that work with me. And this is my email ID. The slides will be up later on. And thank you very much.